let's get into it. Today we are talking about a really fascinating split that's happening in the world of AI. It's called the bifurcation of intelligence. We're going to look at what's basically a showdown between the giant large language models and their much smaller, scrappier cousins. Hey, welcome everyone. So for the longest time, the story in AI has been pretty simple, right? Bigger is always better. But, a really powerful countertrend is starting to pop up, and it could totally change how we all interact with artificial intelligence. So think of it like a boxing match. In one corner, you've got the heavyweights, the absolute giants of the industry, large language models, or LLMs. And in the other corner, we've got the nimble speedsters, the small language models, or SLMs. And they represent two completely different philosophies on how to build intelligence. Okay, so LLMs are the ultimate generalists. I mean, think of them like a massive library that can talk about philosophy, write computer code, or even draft a movie script. SLMs, though, they're specialists. They are laser-focused and trained to be experts in one very specific thing. So you gotta ask, in a world that's obsessed with massive scale, why would we ever want something smaller? Well, the answer is hiding in how they're built. The most just striking difference is their scale. And we measure that scale using something called parameters. Now, you can basically think of parameters as the model's internal neurons, or, its knowledge connections. The more you have, the more complex the stuff it can understand and process. A typical LLM, like the big names you're always hearing about, can have over 175 billion parameters. That number is just colossal. It takes massive data centers, it burns a huge amount of energy, and it lives pretty much exclusively in the cloud. An SLM, on the other hand, usually has fewer than 7 billion parameters, and sometimes a lot fewer. This huge difference in scale means an SLM is lean enough to run right on your laptop or even your phone, completely offline. This is a huge deal. It puts powerful AI right into your hands. Now, it's really easy to look at those numbers and just assume the smaller model is, well, less capable. But this is the key. Small does not mean stupid, which brings up a super important question. How can something so much smaller be so incredibly effective? Well, it all boils down to power versus precision. See, this massive size difference creates totally different strengths and weaknesses, which makes them perfect for completely different kinds of jobs. It is all about using the right tool for the right task. Okay, so an LLM is perfect for tasks that need broad, creative, or really complex reasoning, like, say, writing a sci-fi novel. It's got to pull from history, science, literature, the whole shebang. But what about a hospital chatbot? Its job is to quickly and privately check a patient's medical records. It doesn't need to write poetry. It needs to be fast. It needs to be accurate within its narrow field. And, this is critical, it needs to protect patient data by running offline. Now, that is the perfect job for an SLM. And get this. This specialization has a staggering impact on cost. Just look at this data for a business handling 1 million queries a month. Using a big cloud-based LLM could run you about $45,000. That same workload on a specialized SLM, just $250. That is a 180 times saving. It's just wild. In this slide, it perfectly illustrates the trade-offs. While the giant LLM totally wins on general accuracy, the little speedster SLM just dominates on cost, speed, and privacy. And it's all because it can run right there on your device, no internet needed. So that brings us back to that key question. If SLMs have fewer parameters and they're trained on less data, how in the world do they become such precise experts? Well, the secret, it turns out, is having a really, really good teacher. The technique is called knowledge distillation. The best way to think about it is like an expert teacher, that's our powerful LLM, training a dedicated student, our compact SLM. The whole goal is to transfer the teacher's huge knowledge about one specific subject directly to the student. So how does this training session actually go down? Well, imagine this. The teacher LLM acts like a master craftsman, and it just generates thousands of perfect examples for one single task. Then, human curators come in, and they pick out only the absolute gems, the A-plus gold standard answers. The student SLM is then put through this intense boot camp, training only on this super concentrated, expert-level data. And the result? A lean, mean, specialist machine that can perform its one job at a level that rivals the very giant it learned from. So you see, this isn't really a story of LLMs versus SLMs. It's not a competition where one of them has to win. The future is actually one where they work together in a really smart collaboration. And that leads us to what's called the hybrid approach. So a fast, cheap SLM sitting on your device handles, say, 99% of your routine requests. But the moment a query is too complex or out of scope, it automatically passes it up to a powerful LLM in the cloud. This layered, cascade system gives you the absolute best of both worlds, incredible speed and privacy for most tasks, with the power of a giant on standby for when you really need it. So, the crucial point is this. The race isn't just about building the biggest model anymore. It's about being smart. It's about choosing the right size, the right cost, and the right tool for the job, you know? Sometimes you need a sledgehammer, and other times you need a scalpel. This shift towards smaller, specialized models that run locally on our own devices, it just opens up a whole world of possibilities for truly personal and private AI. And it leaves us with this final, exciting question. With this kind of powerful, specialized intelligence available everywhere, on every device, what incredible problems are we going to solve next?